The universe is an immense and amazing place, and although the Earth is an extraordinary planet, it is but a tiny dot in the cosmic vastness. With technological advances, humans have been able to send rockets and satellites into space, which has sparked an insatiable curiosity to discover the secrets of the universe. Although we have a reasonable understanding of how the cosmos works, much of this knowledge is based on hypotheses and assumptions. This is where the Voyager 1 and Voyager 2 space probes play a vital role in expanding our understanding of the universe. These spacecraft send back real-time data that enlightens us about the various aspects of our solar system and interstellar space, places we may not be able to visit for many years. But what happens when the data contains a disturbing warning that challenges everything we thought we knew about the universe? Join us as we explore what Voyager has discovered so far and the disturbing message it has conveyed about the future. For nearly 50 years, the Voyager missions have led space exploration, providing invaluable information about the mysteries of our solar system. It is surprising to think that these missions were not designed to last that long, considering the enormous amount of data they have provided. The history of the Voyager program is fascinating. It all began with the accidental discovery by Michael Minovich, who realized that a spacecraft could take advantage of a planet's gravity to propel itself further into space. This led to the launch of Voyager 1 and Voyager 2 in 1977, with the goal of studying Jupiter and Saturn. What happened next was almost a miracle. Both spacecraft are equipped with 3.5-meter parabolic antennas and 16 thrusters to adjust their orientation and keep their antennas pointed toward Earth. Their engines run on hydrogen as fuel, and their electronics are powered by plutonium-driven thermoelectric generators. In addition, each probe carried 11 scientific instruments, half of which were designed to study the planets and have since been shut down. The grand tour of the 4 planets has become one of the greatest achievements in space exploration. Voyager 2 achieved the first close observations of Uranus in 1986 and Neptune in 1989, while Voyager 1, which overtook Voyager 2 a few months after its launch, flew over Jupiter in 1979 and Saturn in 1980, becoming the most distant man-made object from Earth. Today, Voyager 2 is still operating with 5 active instruments, while Voyager 1 has 4 in operation, but both continue to be instrumental in collecting valuable data about the deepest regions of space. Today, both probes are traveling beyond the Sun's influence into interstellar space, sending back crucial information about the cosmic environment. Before exploring the messages Voyager 1 has sent, let's review some of the findings both missions have made along the way. Imagine embarking on an epic mission to explore the unexplored parts of our solar system with trusty Voyager 1 and 2 at your side. Their first task was to take a close look at the majestic Jupiter and Saturn systems, and they did so successfully, sending back polished images and collecting data that transformed our understanding of these gas giants and the famous ring planet. As Voyager 1 left the solar system behind and entered interstellar space, Voyager 2 still had exciting tasks ahead. In 1981, a maneuver adjusted its course toward Uranus, and after far exceeding its planned lifetime, it arrived at the distant frozen giant in January 1986. During its journey, Voyager 2 discovered 10 previously unknown moons, adding new members to Uranus' family of satellites. But its journey did not end there. Its final destination, Neptune, resulted in the capture of more than 9,000 images and another astonishing discovery, 9 new moons. Triton, Neptune's largest moon, also revealed fascinating secrets. Its diameter was different than previously thought, and it had surprisingly few craters. In addition, its whitish-brown color was a result of geysers spewing liquid nitrogen, which froze as white nitrogen snow on the surface. With these astonishing discoveries, the Voyager mission left an indelible mark on our understanding of the nearby universe. No other probe has revisited Uranus and Neptune since Voyager 2, but scientists have continued to observe and study amazing phenomena on these planets from afar. Now, get ready to discover the secrets behind these mysterious celestial bodies. Uranus, among the small group of ice giants in our solar system, is joined only by Neptune. Despite what its name suggests, much of the matter on Uranus is not frozen. For the most part, it consists of high-temperature, supercritical fluids composed of volatile substances such as water, ammonia, and methane. These fluids combine the properties of both liquids and gases. Uranus, located about 1.8 billion kilometers from the Sun, is the second most distant planet in the solar system, with a diameter more than 4 times that of Earth. It takes about 84 years to complete its orbit, and while doing so, it has a curious characteristic: it rotates lying on its side. Although it is not known for sure why, scientists suggest that an early collision with a large protoplanet could have caused this tilt. This could also explain the 27 moons that surround it, possibly formed by the debris from the impact. As if that wasn't fascinating enough, about 10 years ago, the Hubble Space Telescope detected a huge white spot in Uranus' atmosphere. It was a gigantic storm, with winds reaching up to 143 kilometers per hour. In addition, in Uranus' icy clouds of methane and ammonia, temperatures can drop to minus 197 degrees Celsius. And although less noticeable than Saturn's, Uranus also has a faint and more dispersed ring system. Neptune, discovered in 1846, is the farthest planet in our solar system, located almost 5 billion kilometers from the Sun. At this distance, it is a loner in the cosmos. To put it in perspective, the distance from the Earth to the Sun is only 150 million kilometers. Despite its remoteness, Neptune is similar in size to its neighbor Uranus, with a diameter of 50,000 kilometers. Neptune takes 165 years to complete one orbit around the Sun but rotates rapidly on its axis, completing one revolution in just 16 hours. During the visit of NASA's Voyager 2 probe in 1989, extreme weather phenomena were observed, such as luminous bands of clouds and storms with winds reaching up to 2,100 kilometers per hour, the fastest ever recorded on a celestial body. Scientists believe that the low solar energy reaching Neptune may allow these storms to reach such speeds, although they may eventually disappear. During the Voyager 2 mission, the Great Dark Spot, a giant Earth-sized formation thought to be a feature in the planet's cloud cover, was discovered. However, when astronomers tried to locate it again a few years later, it had disappeared. Some theories suggest that the heat from Neptune's core caused atmospheric turbulence that disintegrated the structure. Speaking of Neptune's core, despite the planet's volatility, scientists estimate that it has a massive core with a mass between 1 and 1.5 Earth masses, composed of metal and rock. Temperatures within the core are believed to reach nearly 13,000 degrees Fahrenheit, with pressures of several million bars. The magnetic fields of Uranus and Neptune have also long puzzled scientists. Let me know what you think in the comments box. If you like the video, don't forget to hit the like button and subscribe.